In this recording, we are going to talk about order of operations. We're just going to do some simple examples here. First of all, you remember the mnemonic PEMDAS. P stands for parenthesis, and P stands for any grouping symbols, so parentheses or brackets or braces sometimes. So anything that tells us the order in which to do things. Oh, here's one that we don't often think about. The fraction bar is a grouping symbol. We'll see that. E stands for exponents, anything raised to a power. We won't talk about that in this recording. M stands for multiplication, and D stands for division, but I find this to be a little confusing. We don't actually do all the multiplication first and then the division. The rule is we go from left to right, doing multiplication and division as we come to them. And the same thing for addition and subtraction. We don't really do all the addition first and then the subtraction. We just go left to right, doing addition and subtraction as we come to it. So that's the first rule. Move left to right and do the operations in this order. Multiplication and division first, addition and subtraction second. So in 9 plus 5 times 2, we will do the multiplication first. 5 times 2 is 10. And then we'll write down the rest of the problem. Now, that is the most important key to this whole thing, and that is you do one operation, whatever the next operation is that you're supposed to do, in the proper order, and then you rewrite the whole problem. And I know that a lot of times we resist this. We like to do the problem in our head. We like to be able to kind of do this without writing anything down, but it's super, super important that you show yourself the work by rewriting the problem with one bit, maybe two, simplified. So I rewrote this. 9 plus, instead of 5 times 2 is now 10, so 9 plus 10 is 19, and that is my answer. Okay, in our second problem here, we're going to do the same steps, move left to right, but we notice that there are grouping symbols here, parentheses, around one of the operations. 9 plus 5 is inside parentheses, times 2 is outside. So it's the same exact numbers, same exact operations, but the parentheses tell us do what's inside first, 9 plus 5 first, instead of the times 2 first. Okay, so 9 plus 5 is 14. And then I like to keep the parentheses there, just in case, and you can see here that it is important. I keep the parentheses there to remind myself that this is a multiplication problem. If I took away the parentheses, it'd be hard to remember that that was multiplication. You can do it, but you just have to have some mark there that says we're multiplying next. All right, so 14 times 2 is 28, and that's the answer. Now you can see that order of operations really matters, because if you get the wrong order, you're going to get a very different answer. So if we changed up the order, one order we get 19, one order we get 28, two very different answers. So in math, we need to get the same answer every single time. So it's really important to keep clear what the order of operations rules are so that we're following those carefully. Let me give you one that's a little bit more complicated that has a grouping symbol in it that is a fraction bar. So the fraction bar says, this is the best way to think about the fraction bar, is it's a grouping symbol, and it's just saying do everything in the numerator and then do everything in the denominator, and then you can deal with the fraction afterwards. So in the numerator, moving left to right, we have 8 plus 3 times 2. We do the 3 times 2 first, so we end up with 8 plus 6. The denominator, we don't have any multiplication, so we could say the rule is don't do anything until we're done with all the multiplication. But because of the fraction bar kind of separates the two pieces, we can do that 4 plus 3 if we wanted to. I'll go ahead and wait till the next step. So 8 plus 6 is in the numerator. We do that first. 8 plus 6 is 14. And then 4 plus 3 is 7. And now this fraction bar turns from a grouping symbol, telling me to do the numerator first, the denominator first, and then apply the fraction bar. It turns into a division problem. This is 14 divided by 7, which is 2. So those fraction bars can be tricky because they mean two things at once. One is the grouping symbol, separating the numerator and denominator, and one is as a fraction bar is a division symbol. And if it didn't go in evenly, 14 divided by 7 didn't come out evenly, we would have had to keep the answer as a fraction. Okay. Now, that's all you're going to be asked to do with these grouping symbols and order of operations. I want to show you one last time, and this is the messy one here. You won't be asked to do anything this horrible, but I want to show you that this process works every single time. So here I've got this horrible big problem. I didn't want to read it up there, but we're going to follow the rules and simplify this step by step. So first thing we do is we look at the grouping symbols, and the grouping symbols include the fraction bar. So we're going to do the numerator one step at a time, and at the same time we'll do the denominator one step at a time. Second, we have a grouping symbol in the numerator, the 7 minus 5, so I'm going to do that first. And we have a 9 minus 7 in the denominator. I'm going to do that first as well. Let's go ahead and rewrite this once. So 12 plus 5 times 6 minus 15 times 7 minus 5 is 2 plus 1. We'll rewrite the denominator. 3 times 7 plus 6 minus 4 times 9 minus 7 is also 2 minus 6 divided by 3. Okay, now let me show you something else. I'm going to try to get a different pen going here. Let's see if I can get this to work. I'm going to highlight all of the addition and subtraction. The addition and subtraction are the operations we do last. And you can think of the addition and subtraction as kind of being a dividing markers for this problem. So I've got a plus sign there, I've got a minus sign there, got a plus sign there, plus sign, minus sign, minus sign. Okay, now why did I do that? It really kind of messed me up because it changed my made it hard to see my operations there. Maybe I better go put them back in. Plus, minus, plus, plus, minus, minus. I'll have to find a better highlighter in the future. But notice that we have some operations here, I'll mark them in red, between the plus signs and the minus signs. So we have a multiplication here, a multiplication here, multiplication here, and then a division there. And because all of those multiplications and divisions are separated by plus signs or minus signs, I can do them all at once. So that's my next trick, is I can do operations, more than one operation per line. So I don't have to rewrite this problem 1, 2, 3, 4, 5 times to get all those multiplications and divisions done, as long as they're operations that come later, separating them. So that 5 times 6 is separated from the 5 times 2 by that minus sign, so I can do them both at the same time. So I'm going to do that. 12 plus 5 times 6 is 30, minus 5 times 2 is 15 times 2 is 30, plus 1 over, let's see, 3 times 7 is 21, plus 6, minus 4 times 2 is 8, minus 6 divided by 3 is 2. Now I'm going to do the addition and subtraction in order, and yeah, you can cheat a little bit on this if you're able to do more than one at a time, but you have to be kind of careful here. So 12 plus 30 minus 30. I think you can see that if you take 12 and add 30 and then subtract 30, you're going to get just 12 plus 1 is 13. Okay, so I'm not going to demand that you be completely unreasonable. I'm not going to be completely unreasonable and say you have to write out once again, every operation that you're doing. But you do want to be careful, and if you do skip a couple of steps and make a mistake, you want to go back and do it again and go slower and show more steps. All right, so 21 plus 6 is 27, minus 8 is 19, minus 2 is 17. I have a suspicion I did that wrong, so here's what I mean. I'm gonna go back and I'm gonna show my steps here. So I'm gonna just say to myself, and maybe I made a mistake and you can see it and you're yelling at your computer screen, but I'm just gonna say, okay, so 12 plus 30 is 42, minus 30 plus 1, and 21 plus 6 is 27, minus 8, minus 2. And then I'm going to do it over to the left. 42 minus 30 is 12, plus 1. And 27 minus 8 is 19, minus 2. And that's 13/17. So 13/17 is the answer. We could type this in the calculator and get a decimal answer, but I think you will know, and if you try it, you'll definitely know, that it would not come out evenly or neatly. So in that case, and in general, we prefer fractions to decimals in algebra. So keep that answer in fraction form. You don't have to actually do anything with the fraction, but we want to keep it as a fraction in our answer. All right, thanks for watching. I hope this was helpful. Have a great day.